We have our last chapter, which is chapter 16, which is a natural crossover from how we looked at percentages. If we look at the previous example, 1512, exercise 1512. Something familiar? How did we handle that one? Well, one school had a decline in enrollment of 12% and now has 352 students. How many students did the school have? If we just do it again, we said let a question mark in a box represent the original, I think she said, student count. I think those were the exact words that she used. Then we can use that missing quantity to translate the given information into a mathematical sentence, and that is exactly what it is, just a translation. Decline in enrollment, so a decrease of 12% results in 352. So that means 0.88 times the original is 352. Now I don't care about solving it, we've already done it. The only crossover issue that we have to realize is that I am not in any way restricted to a question mark in a box. It could be anything you want it to be. It just represents a number that I don't know right away. So I can call it squiggle. Then this is of course the same thing. You can use any symbol you want. So then why make up weird symbols if we can just use letters? And the letter of choice is usually an X. Because X is the mysterious letter. Who knows why? Doesn't matter. But the problem is if I introduce it with an X first, people read too much into it. It's just a symbol. You can use any symbol you want. But instead of making a brand new symbol, which I think we should, but we don't, we use a letter instead. Everything else is the same. That still represents a missing number, and I call this a variable, which is an unfortunate name because it doesn't change. It's a number. Variable indicates it could be many things. No, it's one thing. I just don't know what that number is. So sometimes it's an unfortunate name. Regardless, I don't do anything different. I have a multiplication sentence that I can convert to a division sentence, which is 352 divided by 0.88, and I can find it and blah, blah, blah. Everything else is the same. So there's only really two issues here. One issue is don't feel restricted by what I call the missing number. You can use anything you want. You can be creative, you can make little drawings, doesn't matter. But wherever that symbol is, it represents that missing number. We call that symbol a variable. It could be any symbol you want. The other issue is that, yes, writing a multiplication sentence to a division sentence and so on, those are fine to do when the sentences are simple and straightforward. One multiplication, not mixed with other stuff. So when we look at this mathematical sentence, that is of course called an equation. Anything with an equal sign in it is called an equation. We want to just establish, I don't want to say rules. Rules is a bad word because it feels like someone's telling me what to do. That's not the case. I just want to look at these equations and see, are there consistent properties that tell me how to go from one version to another version. A slightly more complicated version perhaps, to a simpler version. This one can be considered simpler because the variable is alone on the left and I have a calculation on the right telling me what the variable's value is. So in some ways it is a simpler version, but the exact same information. So it's fairly intuitive, to be perfectly honest. We will do it by 2 examples. You can look in the book for discussion and then the example we're going to do. But I will save you from that because it is fairly straightforward. Just to show how can I work with these equations. First one is 16.1, where I have a missing number called x, and I'm adding 2 to get 8. Super easy, super easy. But the property that we observe here translates to much more complicated, or transfers to much more complicated equations as well. I might take a simple one because we all know the answer is 6. But how do we intuitively get there when this doesn't seem intuitive at all? 2 sum. Well, I use a balanced scale. Now the book ones look different than mine. Equal means this left-hand side quantity is the same as the right-hand side quantity, so they're in balance. And I have some x quantity there, and then 2 ones, which are identical, even though my drawing might not make them look identical. And then on the other hand, here I have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. All stacked up there, and everything's in balance. Completely intuitive. What would I have to do to get the x block alone on the left? Little Timmy is totally going to agree, take 2 off on either side. Because if I just take 1 off, then it's going to tip in one way or the other. So I remove 2 on both sides, and everything will be fine. Completely intuitive. Take away 2 here. I take away the exact same amount there, because each block with a 1 on it is the same. And that tells me that x is equal to 6. Nothing to it. Totally intuitive. But that tells me that there's a property that if I subtract 2 on both sides, I have the same information captured in this equation. It's the same. It is essentially the same equation. It just looks simpler, to the point where my variable value can just be read off. Same as the previous one here. The variable was mixed with other numbers. Rewrite it to a simpler looking version where I can just read off the answer. That is the goal. So that's the one for addition, some an equation with a plus. And for subtraction, you can have the same argument by simply adding blocks instead of taking them away. So I'll leave that one. The other example is 16.2. So I don't want to waste your time too much by repeating what's already in the book. You can read it if you want to. There I have an equation, 2x equals 8. What kind of mathematical sentence is it? An addition, subtraction, multiplication, or division sentence?
Multiplication.
If there's nothing between the number and the variable, there is a times symbol. You can totally put it in. But, math is all about being lazy, efficient, and writing less to a point is efficient, I suppose. So when it's a number and a variable that you're multiplying together, we don't write the times symbol, and we all agree how to read that. So what does that mean? Well, it's an equal sign, so everything is balanced in my scale. I have 2 x's, 2 x blocks. Whoops, that does not look like an x. Stacked, however, I don't care. And I have 8 of these little ones. 1, 4. I'm going to stack them like this. There they are, 8 of them. Everything's in balance. Perfectly intuitively, how do you get 1 x block alone on the left side? This is where you say something. If I have double the amount that I'm looking for, what should I do on both sides so everything's still in balance?
You should divide by 2.
I should split this in half and then split that in half as well. Then everything will be in balance. Still. So I'll just say casually split in half. But what am I actually doing when I do that? I'm dividing both sides by 2 to get x equal to 4. Again, the information in the equations, these are the same equations. They just look. One looks simpler than the other, and the simpler version is so simple that I'm reading off the answer. So, this leads me to, I'm not going to call them rules, and I invite you to not call them rules ever. Because if you're telling me to use a rule versus telling them how equations work, one creates negativity and the other one a little less. If you're telling a kid to do something because it's a rule, they're instinctively not going to want to do it. So, there are 2 things we can do to an equation so that the information that's captured in it is the same. So let's write that out. What did I just say? Let's just say it like that. The 2 things one can do to an equation without changing its information, what it's saying. It's a sentence, it's trying to say something. Think of these as English sentences. They mean the same thing. They're saying exactly the same thing, but on the surface it looks as if you're saying it in 2 different ways. So the 2 things we can do is, only 2, it's so nice, just 2. Add or subtract a number or quantity, whatever the quantity is, number, quantity, whatever, on both sides of the equation. And these things you already know, just making us a little bit more aware of it. How to say things, why we can do it, things like that. And the other one is multiply or divide by a non-zero number or quantity. Usually this one will be a number on both sides. So essentially in terms of the 4 basic operations, it's saying do whatever you want. As long as you do it on both sides, everything will stay in balance. And when it comes to multiplication and division, you shouldn't use a 0 because it doesn't really capture the same information then. If I multiply both sides by 0, yes, technically it will be in balance because the scale will be empty, but there's no information in an empty scale. So I lose information if I use the 0 here, but it doesn't really come up as an issue for us. But it is a technicality we should remember. Plus, I can't divide by 0 anyway. It's not allowed. So, keeping those things in mind, I just have one example, really. 16(3). So, to just enforce that. And if we stop thinking of these as rules, but rather just the way equations work and what I'm doing to this equation, then it's really not scary in any way, for any level. I personally like to see it as a game, like a little puzzle. Like, what are the sequence of steps I need to take to make this look so simple that I'm essentially reading off the answer. Now, that one's fairly simple still, so the steps should be easy to find. First, I want to get rid of this negative 1 by adding 1 to get 3x equals 15, and as long as I do it on both sides, everything's fine. Now I'm going to divide both sides by 3 to get x equal to 5. Again, this, in terms of the information that it holds, this is the same as this is the same as this. But the last one looks nicer in that I can just read off the answer. They are the same equations. And we forget what we're doing when we apply these properties. We forget what we're doing. We think we're changing the equation, we're not. We're just giving it a little facelift. The information's the same, the equation's the same. Any questions on that? Or observations, comments, insights, reflections? No reflection? All right, now we're doing the same thing, but wrapped or hidden behind a word problem. 16.4. 2 times a number increased by 1 is 15. Can we define a variable, set up an equation to solve this problem? What do you want to call the variable? Don't feel restricted by x. Anything you want. What do you want to call it?
N.
N. N for number. And it's actually nice to mix it up, because then that helps you to remember that you can make anything you want there. Anything you want. As long as you consistently use the same symbol. Let n represent what? What does n represent? If we can't say it in words, we can't go to an equation. What does n represent? It represents something. What does it represent? Yeah, there's only one missing number here. You can call it the original. The original number. Now, yes, in terms of the grade, this is a little bit on the higher side. Maybe grade 7, maybe a little beyond, but it's okay. But you'll see kids just jump to an equation without really understanding what the variable represents, and then not being able to interpret the answer and get what they look for. Then, I want an equation to represent the information that's given. 2 times a number, well, our number is n, so 2 times n plus 1, increased, yes, so plus, is 15. There I have an equation. Now I don't care where this equation comes from or anything, I'm just solving the equation. Subtract 1 on both sides in this case to get 2n equals 14. Then divide by 2 on both sides to get n equal to 7. Is there anything missing in my presentation of my solution? Including sentence. Yes. I'll put it over here because this is a little low. The original or missing number is 7. Doesn't seem like much, but it's a very good habit to get into to wrap up everything. Alrighty. Very, very handy problem-solving tool. Even though I may not teach it directly like this to little kids, I know I have it if I need to figure out a problem. And then once I figure it out, I can think, okay, how can I represent this or get to this answer in other more intuitive ways, perhaps. So, not to make a big deal of it, but I have other properties to simplify calculations. We call them expressions. We have 3, the commutative property, the associative property, and the distributive property. Which, when you think of these with numbers, is really nothing. This one says, I'll do an example first. If I have 2 plus 3, it's the same as 3 plus 2. No one's going to question that. No one's going to question that. I can use a minus. I can't use a minus, only a plus. But if I do a multiply, then it's also the same. So these only apply to plus and multiply, because those are really the only 2 operations. The other ones are just those in disguise. So these properties are only defined for plus and multiply. So then you can say, more generally, for any a and b, if I add a and b, they represent any number, doesn't have to be a 2 and a 3, I can flip them around. And if I multiply them, I can do it in any way that I want. So as soon as you go to letters or variables representing numbers, people read it differently, but it's not different in any way. So you use specific numbers to convey the property, or in general, doesn't really matter to me. Associative property, if I have 2 plus 3 plus 4, I can do the 2 plus 3 first, and then the plus 4. Or I can do the 3 plus 4 first, and then the 2. Actually, I'm just going to do these with numbers. Doesn't matter. We're not ever going to really state them in general. For multiplication as well, if I have 2 times 3, and I multiply that by 4, I could have multiplied the 3 and the 4 first, and then the 2. It really doesn't matter. And that's easy to convince someone that that is going to work for any numbers. Distributive property is the one that mixes the 2. If I have 2 times 3 plus 4, I can do it in 2 pieces, 2 times 3 plus 2 times 4. Less intuitive perhaps, but you can do it with little blocks. Can be done. There's no need to state these things in general. You have properties concerning both separately, and then one that sort of links them together, because they are linked in a way. That one only goes one way, not the other way. I can't swap the plus and the multiplication. All right, so those are things to keep in mind, but probably all of you know them already, just to work with equations and make them a little simpler if I need to. I have a little example for that, 16.5, where I have something that's going to require some properties first, before we, and maybe in using those properties, I will have a simpler version of the equation to just read off the answer anyway. So let's have something like 2 times x plus 4 equals 7x plus 2. We have to see x just as another number. It could be a 3 for all I know. I just don't know what it is. But it doesn't behave differently in any way. So I use the distributive property here to get 2 times the first one plus 2 times the second one in the bracket. And the right-hand side stays the same for now, working on this side. So 2x plus 8 equals 7x plus 2. Now, what can I do? What can I do? What do you want to do?
Subtract the 2.
Subtract the 2. There's not one path. The end result would be the same. 2x plus 6 equals 7x, and that's it. Something else that I want to keep in mind, and while I'm on this example, show it, that if I have the left-hand side equals the right-hand side, I can flip them around if, for some reason, you like the presentation of that way a little better. Doesn't matter. Don't feel restricted by which side is which side. It's just two sides. And then I can subtract two x's on both sides to get 5x equals 6. So remember, this is a multiplication sentence. I can write it to a division sentence. What am I doing here? I'm dividing both sides by 5. So x is 6 divided by 5. Now you can go in many ways. You can go and say it's a fraction. You can go and say it's a mixed number. You can do the decimal version as 1.2. They're all the same. Doesn't matter to me. Depends on your audience, really. Mixed numbers are really just for little kids. Wouldn't do this for too long. But either one of those, totally fine. Doesn't matter to me. Different representations of the same quantity. All right, so that's sort of the detail that we have to just mention before we go back to the point of all this. And the point of all this is it is a problem-solving tool, a very, very powerful one. And it's a shame you can't teach that earlier. But I mean, the concept of a variable is introduced very early. Just not the full equation thing, but the idea of a variable comes in very early. So it is worth knowing more about that so you're comfortable with it. Now we want to go back to the word problem. So there are 4 steps that I've mentioned before. First step is define the variables that you want to define. Symbols, whatever, letters, doesn't matter what you call them, but you have to start by saying this is what my variables mean, and then I'll go and use them. So before we solve the whole problem in one go, we should just make sure we're happy with those first steps, because they are really what sets me up for success. So let's just worry about those first 2. A group of friends collect comic books, write an algebraic equation. What makes it algebraic? What does that mean? Algebra. Any variable, and you're calling it algebra, though it's not really any different. Still numbers. Or inequality, but we'll get to that when that happens. For each of the following in terms of the number C of comic books that KC owns. So they define a variable for me. They say C, I don't have to do it again, I'm just reminding myself. C represents the number of comic books that KC owns. So once they define a variable for me, I can't change that one. C is what it is. I can use it, and I may need to define my own. You may introduce new variables, but make it clear what they represent. So C is the number of comic books that KC owns. Now, how do you pronounce that? K has 3 times as many comic books as KC. So let's say, maybe a little k for k. Let that represent the number of comic books that K owns. Is this in the camera still? Yes. Then, see how these are always the same. Let a symbol of your choosing represent some quantity. Then there's an equation to translate the information that's given. K has 3 times as many comic books as KC. What is the equation? There's not an equation because it doesn't have an equal sign there.
3K equals C.
3K equals C. Did I hear you correctly? No, at my age I should check. The hearing is the first thing to go, they say. Because I think that's what they say. I can hear them. How many of you agree with that? How many disagree? How many have no feelings whatsoever towards any of this? There's only those three options. Can't be anything else. No thoughts? No
I
opinions?
think maybe.
Yeah, I think 3C. Yeah.
Okay, so obviously it's between those two, right? It's one or the other. How do I choose which one it is? I've had that with students, not you guys, school students. How do you choose which one? Because that's a common issue. Because somehow when we have letters, we think differently. How can you, as simply as possibly, explain which one to go for? Which one is, how do you know which one's correct? Because not everyone has the insight that you might have and just the natural feeling or experience. Yes.
Like in the question, it's given that Cassie have C number of comic books that she owns,
Yeah?
and in the first part it shows that K has 3 times as comic books as Cassie have, so 3
Yeah.
times of C. So
You know, that's obvious to you, but from experience, in no way does it help. Not to criticize you, you're totally right. Everything you're saying is right. But you're really just saying the same thing again. How can we do it in another way to help them see? Because them reading the question again in no way reveals it, like it does for you, right? It's hard to imagine, but some people read this and you can read it 5 times, it doesn't mean anything in terms of choosing which one. How can we say, how can we make it easy to pick which one? From my experience, use actual numbers. Then suddenly it's so much more clear. Instead of a C, let's take an example number. I don't know what C is, but let's pretend it is what?
100.
100. Nice number. Easy to work with. No one's threatened by 100. Then, if the number of books that K owns is 3 times as much, does K have more books or fewer books?
More.
Intuitively, more books. So, or you don't even have to say that. If K has 3 times as many, just having a number instead of the C, they will naturally say, clearly he has, or she, he or she, I don't know, K, owns 300 books. Much more intuitive. So now, this is 300, they'll tell you. So which one of these can be correct? 3 times 300 equals 100? No, clearly not. 300 equals 3 times 100? Yes. But as soon as I have numbers, it just becomes so much less intimidating. Now, make sure you make it clear that we don't know what the numbers are, but let's pretend. It makes it easier to relate these quantities. So it is not that I don't know what the numbers are, and I'll never know. But it gives me a way to verify an equation. And you came up with 100. I was in no way restricted by the 100. That's a hard skill. I can't just repeat the question, because if it was obvious, they wouldn't have made the mistake. Any thoughts on that? Any other ways you might think of? Oh, there's many more questions. Let me know. Nancy has more than twice as many comic books as Casey. First of all, variable. I'm going to be not very original and just use the first letter of their name. Let N represent the number of books Nancy owns. Then, do I set up an equation to represent this information? Or are there other things that could happen let me ask it this way. If I have a balanced scale, I should probably do it on camera. If I have a scale and I'm looking for Nancy, well, not Nancy herself, N, and C, is it in balance or does it tip one way or the other? Now, it's not exactly like more than twice the comic books that Casey has, so a 2C there. Which way does it tip, or is it in balance?
It's in balance.
Nancy has more than twice.
What did you put the two? Is Nancy, does she have more than?
We've already established how to decide that. It's the same kind of sentence as this one. 3 times as many as Casey. Twice as many as Casey. But that's still an important issue.
Did you have to add a new variable?
I'm just asking which way the scale tips.
Increasing.
Towards
Which one's the heavy side, left or right?
Nancy.
Right.
Nancy's the heavy side. Now, in this case, lower means more, which is also maybe a little counterintuitive. So I have an N quantity and twice as many as Casey has. The crocodile eats the bigger one. Crocodile's hungry. It's the bigger quantity. Or the heavier quantity. So the crocodile will eat Nancy's quantity. Not Nancy herself. Only the books. Does that make sense? Yes. Right. I don't know what I'm going to be faced with when I'm teaching little Timmy one day. I have to over-prepare. It's not going to be exactly this. And it's not always going to be variables. It could be one variable and numbers, but the issues are all there. Crocodile, yeah, it's still there, early on. I was never taught the crocodile. I can't remember. It wasn't a crocodile. I don't know. Is the crocodile common? Pretty sure it is. All right. Very important question. And I will reward you in a midterm with questions like this. For putting in the effort now. 3. Where do I get these names? I steal them from textbooks. Jinfa, if that's how you pronounce it, I apologize if that's actually your name, has only half as many comic books as Casey. So, should I just keep going with my first letter or mix it up? First letter is fine. You can use a capital, of course, as well. Let the J represent the comic books that Jinfa owns. How do you feel about that sentence? If you were to grade something like this, let's suppose the roles were reversed, and I write that, and you have to grade it, will you give me my mark or not? You're like, nah, I'll give you nothing. Why not? That is technically not correct. We all understand what we mean. But based on this sentence, it sounds like J is coming as a set of comic books. No, J is a number, not books. It's a difference. Difference. So the number of comic books. J is a number. If you want to play it safe, you can always just have the word number in that sentence, regardless if it sounds perfect or not. You have to make it clear that you understand a variable represents a number, not some other thing like a book. Then, is this an equation that I'm setting up, or is it unbalanced? The only is a little deceptive. Forget the only. You don't need the only word there.
An equation.
It's an equation. That is what, you know, they use these names, and I don't know if it's a he or a she. It's very confusing. That is how many Jinfa has. Very similar to the others, twice as many, 3 times as many, half as many. So the half goes with the C. But you can use numbers, like 100 for C, and then very intuitively Jinfa has 50, because only half as many. But as soon as we have letters instead of numbers, somehow we lose some intuition. We lose intuition, but we gain a lot of problem solving abilities, so that's a trade-off. Intuition's overrated. In this case. 4. Fortuna has 4 more comic books than Kai has. Not Casey. Anyway, let's go with an F to represent the number of books Fortuna has, or owns, or whatever. Then, is it an equation or not? I guess that's the first question.
No.
Because yes was first. She has 4 more. Not just more, but I know exactly how many more. So you want to be as precise as possible, so an equation has a little more information. There's a difference between the sentences. Fortuna has more comic books, and Fortuna has 4 more comic books. One has more information than the other one. So, I have an F, and K has... where's K? I can use my K, and I'll update it in a second. So I'm relating these two right now, because those are the people in the question. It's an equal, she says. But they're not the same. How do I make sure that equal is correct? There's something missing. Plus 4, where does the plus 4 go? Over here. Again, if you're not sure, use numbers. And suddenly it becomes so much more obvious. You can use that, or you can relate it back to C. Is that what the question asks? Yeah, so I do have to use this as a temporary step on the way to that. So F is equal to K, which was 3C plus 4. So that is what we're looking for. Any questions on that? I'm spending time with this instead of the big ones, because there will be a page where I'm just asking things like this. Not the whole problem necessarily. Once I have the equation, the rest is pretty straightforward and doesn't require a lot of thinking. Whatever the equation is, you solve it and you write your concluding sentence. It's not the challenge. The first part is the challenge. That's really where the algebraic thinking comes in. Representing quantities with symbols or letters and then translating the information from the sentence into these symbols. Melissa has 2 fewer comic books than Fortuna has. So, I'll go with my M. Let M represent the number of books Melissa has. Then I can use an in-between equation on the way to my final answer. People are so tempted. I have to write as little as possible. I have to write my final answer right away. No, you can write a lot of things. Whatever makes the journey easier. Melissa has 2 fewer comic books than Fortuna. So it's M versus F. Is it an equality?
Yeah, there's an equal.
Well, am I setting up an equation?
Yes.
Sorry, it's not an equality right there. With an adjustment it will be. What do I add with the equal sign? So the equal sign is true. F minus 2. Let's check. Melissa has 2 fewer comic books than Fortuna. So let me ask you something intuitive. If Fortuna has 10 books, how many does Melissa have? Don't look at that. Look at the sentence. Melissa has 2 fewer. If Fortuna has 10, how many does Melissa have? 8. So is that correct? I'm just checking. Right? We have to check. Because we've made little mistakes in the past. All right, now I'm happy with it. Just checking. Okay, but that's not my answer in the end. What they're looking for everything in C. So M is 3C plus 4 minus 2. You can simplify that, or you don't have to simplify it. The question just asked, use the C. And I had F on the way to C. That's all. So it doesn't matter if you simplify it or not. The answer is still the same. All right, so perhaps some of you find this incredibly tedious. Yes?
So like I know what the question asks here, but if like where it says out, but if you wrote n plus 2 equals f.
Oh, that's fine.
Okay.
You can totally do that. You can do m plus 2 equals f, because we know these are the same, right? And therefore we can do m plus 2 equals 3c plus 4. They're the same. No, there's definitely not just one way to write these. The only requirement the question had was use a c. So hopefully there are some of you that just needs to think about this a little bit, just to make sure about these concepts. Not just in preparation for a quiz, but in preparation for the future. 16.7. Please, also in the test, make sure that you're reading the question right. There are going to be some like this, like 16.6, which just ask me for the equation. Define a variable, set up an equation. Don't solve the equation. You can solve the equation, but that's not what I'm looking for. And in some of those cases, you're just using a variable to express something or translate something. There's no equation to solve. So read the question carefully. And it'll say in brackets, this is not an equation you should be solving, or something like that. I'm only asking half of it, so it's a little easier. In this case, it says write an equation for each of the following using a variable, and then solve the equation. So, okay, we're doing all of it. Fannie's company has a mortgage debt of 120 million, and Freddie's company has a debt of X million. So they're defining the variable for me. Together, their debt is 560 million. What is the debt of Freddie's company? Not a hard question. It's really just getting me used to the variable again, just like before. This is number 1. So first of all, it's not about answering the question. It's about using the variable and equation method to answer the question, even in this simple situation. So what is the equation that translates the information? That is the issue. It's not answering the question, it's translating the question. They define X for me as the debt amount of Freddie's company. That sentence, together their debt is 560 million. How do I translate that sentence? Yes?
Well, it would be an addition thing.
Yeah.
So I would do 120 plus n equals 560.
I can't use an n because I am not defining it. That's the difference. So it's a good point. You did that on purpose, of course. If I'm allowed to define my own variable, you can call it whatever you want. If they define it for me, I have to use their variable. Okay? So watch out for that too. Excellent. Now they do ask in the question, solve the equation. So I'll go one further, but it's so simple. Although to little Timmy it won't be. Whatever grade little Timmy is, maybe 7-ish. Yeah, maybe 7. Depends. And I get 560. Now it's not a full word problem. They're defining the variable and solving, they say solve the equation, not solve the problem. So this is all they're looking for.
560.
560?
I'm just, is it Monday? Feels like Monday, sorry. Let's pretend I did that on purpose to just see who's awake, but that's not. All right, so very simple, just focusing on that variable. Looking out for little things, like they're defining a variable for me. I have to use that, things like that. Number 2, the price of a ticket to Animal World is $32 a day. Tanya bought 1-day tickets to Animal World and to Air Park for herself and 4 of her friends for $300. What was the 1-day price per person at Air Park? A little more to this one. Not as straightforward. So first of all, how many people are involved here? 5 people. And all of them have tickets for everything? No?
No.
Sounds like it to me, but I might be misreading it. What are the ticket distribution? Who has what kind of tickets? Important lesson here, we need to not be self-conscious or insecure about reading it as many times as you need to read it. Especially in a test. No one knows how many times you're reading it. You can read it 10 times. Doesn't matter as long as you are happy and clear about the information. She buys the tickets. She buys tickets to Animal World and to Air Park for herself and 4 of her friends. It sounds to me, but please correct me if I'm misinterpreting it, that all 5 people get all kinds of tickets. Sometimes the wording is weird, and you should definitely check. Okay, so now the question, so the total is 300. So the question is, what was the 1-day price per person at the Air Park? Because I know the Animal World ticket. So now I have flexibility to define my own variable. First of all, what do you want to call the variable? And then, what does it represent? The choice is yours. Do you want to make a symbol? Do you want to use a letter?
Just smiley face.
Smiley face, I like it. Like classic or emoji?
Emoji.
Okay. Let smiley face represent what?
Air Park ticket price.
The Air Park. Let me check my camera here. Do I have space? Oh, lots of space. Ticket price. Because I'm talking about price, the fact that it's a number is implied there. But if you want to be just overdoing it and just throw the word number in there, I'm totally fine with that. It's not a grammar class. I don't care how you phrase it. Then, what am I trying to have on either side of my equation? What is the easy side of the equation? Let me ask that. 300? So the other side is really a calculation, another way of finding that 300, which is representing the total cost of all the tickets. So how can I break it down into pieces? Well, I have 5 people buying tickets to Animal World at 32 per person. And then I have another 5 people buying tickets to Air Park, and it's smiley face per person. Not the only way. You can do, of course, have done 5 times 32 plus smiley face as well. Depends on how you see it. Does that make sense? Where we get that? We're translating the information. So on the one hand, I know the total is 300. On the other hand, I can do it in little pieces and look at the calculation that has to arrive at that 300 as well. Now I have my equation. They say solve it, so I will solve it. So 5 times 32 is what? Let's do 5 smiley face My smiley face needs work. 5 times 32 is 60. So the number of steps to simplify the equation that you should show is totally up to you. It depends on your comfort level completely. I am now just looking for the answer. You can show as many or as few steps as you want. So 5 smiley faces equal 140. So smiley face, let's just emphasize here that I'm dividing by 5. So smiley face equals 140 divided by 5, 28. Now, I think you can get away without a concluding sentence in this case, because it specifically says solve the equation, but it feels wrong. So I'm going to write a concluding sentence. What were they asking for? And double check. I'm going to double check so get the wording right. What was the one-day price per person at airport? All right. Let's just say it like this. Air Park costs 28 per person. Any questions or comments? Yes.
Just one, might be kind of silly. I like to show a lot of detail when I'm doing this.
You can show as much detail as you want.
Okay.
It's actually better. It's actually better to show detail. But time-wise in a test, I understand that you want to optimize it so you don't have to show as much detail. But it's always easier to read if there's a lot of detail. Makes it easier for anyone who reads it to understand. All right, we have more. We have more. 16.8. So we have to be careful of our intuition. And this method of variables and equations is there because guess and check doesn't always work with messy numbers. And the question could be phrased in a way or just set up in a way that's confusing, and my intuition is limited. Intuition varies from person to person, and it's not something I can rely on necessarily. So, the bottle of wine cost $10. The wine was worth $9 more than the bottle. How much was the bottle worth? Let me ask you this. If you were to conduct a survey and you asked this question, just to average people, how many would say $1? Almost all. A bottle of wine cost $10. The wine was worth $9 more than the bottle, so the bottle's worth 10. Sorry, 1. Sorry. $10, $9, 1. Intuitively, it feels like a 1. So let's make sure and see what does the variable equation, which we're just practicing. We could have figured this out in different ways, but it just gives me a structured way to explain why is that my answer to someone that doesn't just see it. So, first of all, what do you want to name your variable, and then what does it represent? That doesn't have to come from the same person. Someone can pick a name, someone can say what it represents.
W.
W represents
Bottle worth.
that sounds a little weird.
The worth of the
No,
bottle.
no, no, there's not a grammar class. The bottle's worth, maybe. That still sounds weird. Whatever, doesn't matter. Doesn't matter, we all understand. The cost of the bottle. All right. Now I want to use W to translate that information into an equation. So a bottle of wine, that is the bottle with the wine, together cost 10. So very similar to the previous one. I have the total cost of the wine and the bottle. How can I break them up to get to the other side of the equation? Well, the wine and the bottle. So let's say here bottle. Very informally, bottle plus wine. Right? What is happening up there? Okay, I don't want to know. Just keep the door closed. Do we have a lock on it? Bottle plus wine, right? Informally. So the bottle is our W. And the wine, the cost of the wine is represented by 1. I'll give you a clue, it's not silence.
Would it be W plus 9?
They say the wine is worth $9 more than the bottle. So I can put it in brackets if I want to, because it's the wine's cost representation. W plus 9. Does everyone agree with that? That's what they're telling me. So this was just informal for me to set it up. So now I have an equation. I've translated the information. By the associative property, these brackets don't actually matter. And I can put the two W's together. And then I have a 9 equals 10. Subtract 9 on both sides to get 2W equals 1. Divide by 2 on both sides to get W equals a half or 0.5. My conclusion, my concluding sentence, the wine costs 50 cents. Bottle, sorry. W sounds like wine, sorry, bottle. It's not my day, all right? Bottle. I was like, yeah, wine? 50 cents? Whew. Sign me up. So it's a little counterintuitive. Maybe not to you personally. You were like, I knew it. But in general, try it with random people or your friends. Most people would say $1. And this method is there to give me an option outside of my intuition. Because I can't always rely on my intuition. Any questions on that? Comments? It's counterintuitive. It is. And there's no shame in admitting it. I admit my intuition is terrible. To the point where I don't even pay any attention to it anymore. I don't even try. Because it's not something I can rely on. Sometimes, yes, but I can't know that in advance. All right. Next one is 16.9. No, not every question is trying to catch me. Intuitive dilemma. Most of them are straightforward, and it's just a matter of going through the motions. David has 3 times as much money as Rick. Together they have $400. How much does each one have? Now, disclaimer, for the purposes of word problems in this course, you can't get away with just, get emotional about this, you can get away with just one variable. Even though there are 2 things we want to know, I want to keep it as simple as possible and define just one variable. We don't need 2, but you can do 2. The problem is if I have 2 variables, I need 2 equations, and it just becomes a little messy. And not everyone likes that. So to simplify things in general, let's define just one variable. And often, not always, it depends, often in a situation like this, I find the easiest variable for me to work with is the smaller amount. Not always, but usually, the smaller amount. So between David and Rick, which one of them has the least amount of money? Rick. So she's going to make my equation a little nicer if I go, let's go R for Rick. R represents Rick. Now, personal reflection. If you're given that in a test, how many of you would write that exact sentence? You don't want to say. Is it right?
Presents Rick's money.
The money, it's a number, it's not a person. R isn't a person. So Rick's money or something indicating number, amount, quantity. That's a variable. It's a common mistake, so I want to point it out every now and then. Then, before we go to the equation, we have another person. We have David. David's money can be represented using this R. I can sort of recycle it and represent David's money with that same variable. It's not going to be R exactly, but it's a calculation using R. If they say David has 3 times as much as Rick, how much does David have if Rick has R dollars? 3R. And that way I can get away with just one variable by using that variable to represent both quantities. Then I can translate the information they give me into an equation. Where is it now? Together they have 400. Well, that's pretty simple. That Rick's amount plus David's amount has to be 400. So you get 4 times R equals 400. You don't have to write the division every time. You can just say it. Especially when it's so straightforward. Then all I need is a concluding sentence and I'm done. My concluding sentence has to refer to both to answer the question. So Rick has $100 and David has 3 times as much, 300. That was pretty straightforward, pretty standard question. But it still comes in 4 steps, if you look at it. First step is define variables and represent quantities. Then my equation is my translation step. Then solving the equation, however many steps you need to show, concluding sentence. Always 4 steps. All right. Pretty straightforward one. I don't want to rush through them, so let me know if you have any questions or comments or concerns or anything at all. Next one is 1610. 1610. One weekend, a store sold twice as many CDs as DVDs and 25 fewer tapes than CDs. What's a tape? Let X represent the number of DVDs sold. So they define it for me. Don't have a choice. I have to use it. Express the number of CDs and tapes sold in terms of X. Just like we used an R there. How many of each were sold if 100 items were sold in total? So there's multiple questions here. They're really just trying to guide me through those steps. So they define X for me. I can emphasize it here to remember it's the number of DVDs. So then the number of CDs is something, and the number of tapes is something else. I should really swap out tapes for something, because who knows what that is. Okay, so X is the number of DVDs. They say they sold twice as many CDs as DVDs. So how many CDs did they sell? 2X. It does get easier, hopefully. Even now. Just a few examples under your belt and it gets easier. And that creates confidence. 25 fewer tapes than CDs. So how many tapes? 2x minus 25, he says, as if it's too obvious to even do. Now, how many of each were sold? If 100 items were sold in total. So now, the given information is, add all of them up, and I get 100. 100? 100. So x plus 2x plus 2x minus 25 equals 100. You can put brackets there, but by the associative property, we know we can group these things together as we want anyway. So I have 5 x's minus 25 equals 100. So 5x by adding 25 on both sides is 125. Dividing by 5 on both sides gives me,
35.
sorry, 30 wasn't listening.
25.
25. I'm not done, I have my concluding sentence, which I'll squeeze in on the side here. The concluding sentence has to refer to all 3 of these quantities. So, they sold 25 DVDs. 2x is 50 CDs. And 2x minus 25, that's 50 minus 25, it's another 25 tapes. How do you find the difficulty of these questions?
Pretty easy.
Very easy. Should I put them in the quiz, in the final?
Yeah.
No, you don't like it? Which part do you not like? There's no wrong answer, I'm just curious. How do you perceive this? It's hard for me to know, right? Everyone's different, there's no wrong answer. Which part do you not like? The setting up part, the translation part, the solving of the equation part, the concluding sentence part?
Maybe it's just an ability to mess up the translation part more so.
Yes, I would say that is the most difficult, the setting up of the equation. It really only gets better. There's good news and bad news, I suppose. That it gets better by doing more, so that means you have to do more. But the good news is there's a very simple recipe to get better. That all I have to do is do more. It's not I have to look somewhere else, I just have to get that experience. 1611. 1611. I mean, another way of putting it that I might have mentioned, I can't remember which class I mentioned what to. When it comes to questions like these, what do you think is the difference between me and you? Is it intelligence? No difference. The only difference that makes this easy for me is I've done like a zillion of them. It's the only difference, only experience. Nothing else stands in your way. There's no deeper insight here that I'm using that you can't have. It's only experience. In a small town, 3 children deliver all the newspapers. Abby delivers 3 times as many papers as Bob, and Connie delivers 13 more than Abby. If the 3 children delivered a total of 496 papers, how many papers does each deliver? Now, because I'm starting to build that experience, I already see this is very similar to the previous one. Very similar. I have 3 things. I can define 1 variable, and from experience, I also know that defining the variable as the smallest quantity will make it just a touch easier. Not that I have to. It's going to give me all the advantages to be successful in this question. But, first of all, I have to decide, if I want to go that route, who is delivering the fewest number of newspapers? Well, Abby delivers 3 times as many as Bob, so definitely Bob is less between those 2. Connie delivers 13 more than Abby, so who delivers the fewest? Bob. So one option is to go with Bob's amount. What do you want to name the variable?
B.
B. Yeah. B represents the number of papers Bob delivers. Don't say B equals Bob. That will make me very sad. Very sad. Then I remember that for this course we only need one variable. So I want to represent the other quantities using this variable B. Abby delivers how many newspapers? 3B. And Connie delivers how many newspapers?
13 plus 3.
I don't remember. So that I don't believe you, let's pretend I actually need to look. Connie delivers 13 more than Abby. 13 more than Abby. So it doesn't matter how you write it. I like my variable first, but that's personal preference. 3B plus another 13. Is this step the problem step? I'm just curious. Don't acknowledge my existence whatsoever. Denial is not the way to go here. Now, I have to accept my experience limitations and work on them. I want to translate the other information, which is the total number of papers, into an equation. And I've been building up my experience. I see it's very similar to this. Put them all together and I get 496. B plus 3B plus 3B plus 13, 496. Now it's just an equation. I have my ways of simplifying and solving the equation. I have 7B's plus 13, 496. So 7B's equal 496 minus 13. I'm not actually thinking, I'm just waiting for you. 483. So B equals 483 divided by 7. Use a calculator, it's fine. 7's not the nicest thing to work with. Do it in your head if you want the challenge. It doesn't matter to me. What do you get? 69. Now I go back. Do I have the space? I'm going to squeeze it in here to just sum everything up. So Bob delivers B exactly. So 69 papers. Abby delivers 3 times as much. What's 3 times 69? 20? 7 papers. And Connie is the last one. Delivers that plus another 13. So 220. And you can always check, do these numbers add up to 496? Sort of as a safety. That doesn't guarantee you did it right, but it does help. The more we do them, the easier they will get. That is not my opinion, that is proven fact. That's how it gets easier. Now, how many you need to do for it to be easy, that depends. But eventually you will get there. And I find the variable and equation method very comforting. That I don't need to have any insight. I don't need to guess. I don't need to know anything. I just go through the steps and I'll find the answer. 12. Three brothers, Tom, Dick, and Harry, ate a whole apple pie. Tom ate twice as much as Harry, and Dick ate 1.5 times as much as Harry. What part of the pie did each brother eat? Now, there's nothing better than a word problem with fractions. It just doesn't get any better. It's really combining your favorite two things into one. Can't think of anything better. I know you don't have to say anything. It's obvious. Now, what do I do for a variable? So we're going to stick to my strategy of the smallest amount for my variable. Just makes it a little easier in general, but in this case, because I have fractions, let's read this again. They all eat the pie. Tom ate twice as much as Harry. Dick ate 1.5 times as much as Harry. So when I read it, all those things are relative to Harry's amount. Whether the largest or not, it might be simpler to define Harry first, because the way the sentences are framed. Let's be unoriginal and say H represents, what does it represent?
How much Harry ate?
How much Harry ate. Then I want to use that H to represent how much Tom and Dick ate. Then Tom ate how much of the pie? Well, it says twice as much as Harry. So that would be 2 times X of the pie. And Dick ate how much? 1.5 times as much. So what do I write here?
1.5.
3 or 2 times that.
You can write that. Just looks uncomfortable. I don't like mixed numbers when I'm actually doing calculations. So you either write 3/2, or you write 1.5, whichever one you prefer.
Isn't it H instead of X? Because we choose H as a variable.
1.5 times as much as Harry, and Harry is. See, I'm so conditioned to use X. I fall for the same thing as well. Mixing it up is a really good idea. I don't even think about it, just write X. Yeah. But not X, it's H. So it's not that the mixed number is wrong, it's just bad form. It can be very easily misread. Of the pie. So it's best to avoid it. All right. Now, can I translate the information? I hope so. But what is the translated information?
Each plus 2 each, that's 1.5 each.
Equals?
1.
1 pie. 1 pie. All right, so I put them all together. I have 3, 4.5. And of course, you can go fractions, go decimals. They're all the same. Doesn't matter. Most people are more comfortable with decimals, so do it this way. So I divide both sides by 4.5. Sometimes people like to write it like this, which you can totally do. H is therefore, what's 1 divided by 4.5? Who knows? Calculator knows.
0.2 repeated.
Oh, that's unfortunate, isn't it? Yeah. It's not wrong in any way. I would have just liked to write my concluding sentence with fractions, because the information was 1.5. Sorry?
The fraction is 2/9.
So you can do either one. It's like nice, more presentable maybe. In line with how the question said things. They said 1.5 and not 1.5. I chose 1.5 for clarity, convenience in calculation, but you can choose either one. It doesn't matter. So Harry 8 2/9 of the pi. I'm just going to write of the pi at the end. Tom ate twice as much, and it's just easier now as well. Obviously 4/9. And what's the other one? Dick ate 1.5 times as much as Harry. What would that be? You can go one of two ways. You can actually use this, make it a fraction. But you know what? They ate 1 pi. So what's the missing fraction? I don't want to simplify it. But you can, yeah. It's a little more obvious that it adds up to 1. If I leave it like that, over 9 of the pi. So in terms of presentation, you have options, decimal, fractions. It's all the same. Doesn't matter at all. In the end, they all ate the pi. Should I put a word problem in the test that has equations, variables, and fractions? No? All right, 13. We're getting there. If we can finish just these 2 last ones today, we are well on our way to have some space at the end of the week. Bruno has 5 books overdue at the library. The fine for overdue books is 10 cents per day per book. He remembers that he checked out an astronomy book a week before he checked out 4 novels. If his total fine was $8.70, how long was each book overdue? People find this one tricky, just so you can take a little bit more care. But trust the process. What is the first step? The other catch that people that people fall for is they try and do too much at once. There are 4 steps. Don't do step 2 before you did step 1. Don't look for the answer, which is step 3 really, before you've done step 1 and 2. Start with the first step. Don't worry about the rest. What are they asking for? How long was each book overdue? So do I want to focus on the astronomy book, or do I want to focus on the novels? That's up to you. Doesn't matter to me. Which one do you want to focus on for the variable? I have to pick one, right? Astronomy book. So then what is your variable name?
B.
B for astronomy? That makes no sense whatsoever.
Astronomy book.
Okay, well what about, okay, fair enough.
Star, since it's astronomy.
Yeah.
All right, I like the creativity. I can do star.
You just do the A thing,
Do the
you're making it way
cursive
more
marks.
difficult.
What is the A thing? I don't
You
know.
write an A, and then a big line through the
Not-
A, not the little one, you write a big line through.
Like this?
Yeah, and then connect the lower ones with the opposite.
Like this?
No, other. Do you need a lesson?
I think I need a lesson in star writing. I don't have your elementary school skills.
Not a skill, man. I learned that in like kindergarten.
Give me a skill that I lack.
So that,
Okay.
and then,
Oh,
I mean, that was terrible, so
No, I
sorry,
understand.
but there you go. Sorry, I'm teasing.
Did not think of that. All right. That would be astronomy, right? I learned something today. See, we all have room for
And
improvement.
then you erase the inside line.
Oh, what, you have to erase these guys?
So, no, you don't have to for this, but like when you're drawing them as a kid, I would erase it and then you'd actually have a nice star. And you can color it in.
See, we all have room for improvement. There's always something to learn. Let that represent the what? Not the astronomy book. What does it represent?
The daily charge?
No, because they give me daily charges 10 cents. So that's not unknown. The time. The time. So let's be specific. Number of days. The astronomy book, I'm just trying to squeeze this in here, is overdue. So it's this one's tricky because of the identification of the variable. Okay. Then, I also need to know how long the novels are overdue. So then the number, it's a little tedious to write these down, but you want to be as clear as possible. Number of days, the novel, or let's say one novel is overdue, is represented by what? Well, I'm going to have to read this again. He checked out an astronomy book a week before he checked out 4 novels. So how long is the novel overdue if the astronomy book is overdue star days?
Would it be star minus 7?
Star plus or minus 7. Well, I'll practice my star while you figure out if it's a plus or a minus. Hey, I'm getting better. Just like word problems, the more you draw a star, the easier the star becomes. She says minus 7. Does everyone agree with her minus 7? How can we help ourselves to figure it out if we're not sure? We've done it before. Pick an actual number. Let's pretend my astronomy book is overdue 10 days. If I checked out the astronomy book a week before the novel, how long is the novel overdue? From 10. 70 or 3? Let's say again. Let's suppose we have a number. Let's suppose I took out an astronomy book 10 days. It's overdue 10 days. I took out the novel a week. Sorry, I took out the astronomy book a week before the novel. How long is the novel overdue? 17 or 3? 3. Because the astronomy book was taken out first, so it has a longer overdue period. But as soon as I have numbers, suddenly it does become much easier. How do I get 3 from 10? I minus 7. All right, we might not finish this one. That's okay. Now, they tell me, actually I kind of want to stop here and let you think about it. They tell me that, yes, it's 10 cents a book per day, per book. And the total fine is $8.70. So clearly, let's go all cents and say 870 cents, right? Because it's 10 cents a book. Do not worry about a decimal point. Just go all cents. It's 10 cents per day per book. How can I calculate my total overdue fee? And then I know it should be $8.70. I'm going to pause there because we have to cross over to you actually trying and thinking. Because the quiz comes and then it's just you on your own. And then we'll start there tomorrow. So we had that. Let's just read the question again to remember, mainly for me. I have 5 overdue books. The fine for overdue books is 10 cents a day per book. And he checked out an astronomy book a week before he checked out 4 novels. So the novels are overdue a little less. And the total fine was $8.70. Now you can go in dollars, but that creates decimal numbers. Why would we bother? So we can also go everything in cents. So the total fee that he has to pay, total fine, is $870. Now how do I calculate the total fine using the different kinds of books and adding them up, obviously? So what is the fine for the astronomy book? You had like 2 days to think about this. No? No one put any thought into this. That's a problem because it isn't the quiz and in the final. No? That doesn't inspire you to do anything? That's final. Who cares? It's only 50%. What is the fine for the astronomy book? Really, no one wants to say anything. You're on camera as not wanting to say anything. Yes.
Would it be x plus 7
Okay.
or 7x?
Make more space here. That is a good question. X plus 7 or 7x? That's what you said, right?
Yeah.
What do I do if the variables are sort of stopping me from figuring out what to do? Assign a number. Let's suppose I had the astronomy book for, what's a nice number? 10 days. Let's pretend it was 10 days. If the fine is 10 cents a day per book, how much do I have to pay for the astronomy book alone? 10 days, 10 cents a day.
100 cents.
100 cents. How do you get 100 cents?
Multiply.
Multiply. Multiply. But now I don't know if it's 10. It's X. What I do with that number doesn't change. So it is 10 times X. But for some reason, I don't know the answer. I don't know the reason. If you look at a specific number instead of this general variable that I don't know what the number is, suddenly it's much more intuitive what I have to do with the numbers, with the calculation. So that when I go back to the variable, nothing has changed. It just might not be a 10. Now, what do I do with a single novel? What is the fine for a single novel? Just move a little bit here. X minus 7. What do I do with the number of days? It's 10 cents a day per book. Well, let's just look at one novel. What is the fine for one novel? Let me rephrase that. How do I calculate the fine for one novel? Just in words, not looking at that. How do I calculate the fine? What is the formula, if you will? What quantities do I put together and how to calculate the fine for a book? Yes, save us.
So I just did the basic kind of conversion of what x would be, and I got x would equal 800.
Whoa, whoa, no, back the truck up. No. Too fast, too fast. Focus on my question, because that'll just create more confusion. No, I'm not saying you're wrong in any way. I'm saying we have to take baby steps to understand this question. We don't know the value of x. That is our ultimate goal. Right now, I am trying to figure out the cost for one novel fee in here. How do I do it? How do I calculate it? You took out a novel. You took it out for, pick a random number of days. How many days do you have your novel?
15.
15 days. costs you 10 cents a day. You're 15 days overdue. How do you calculate your fine? Not look at that. I don't care about that. I'm asking a general question. Let's suppose you are 15 days overdue. You really like the novel, but it takes a while to read. It costs 10 cents a day to have it for 15 days. How do you calculate your fine?
10 times 15.
10 times 15. Maybe it's so obvious you don't want to really say because you already passed it, but I can't tell. But now I don't know if it's how many days it is. I don't know if it's 15. What I do does not change at all. X minus 7 is a number, just like 15 is a number. But that's only one novel. How many novels do I have?
4.
So if I change that to 4 novels, how do I have to adjust that? Times 4. Move this a little bit. So this is a single astronomy book fine or fee. Any questions? It is extremely quiet, which makes me really uncomfortable. Why is it so quiet? Is it because it's confusing? Or is it because it's so simple, you feel insulted that I spend so much time on this? I can't tell. It could be either one. I need to get an app that has cricket sounds. Whenever it's quiet, I'm just going to press the button. Break that awkward silence. All right, so now I have my equation. Now it doesn't matter where the equation comes from, I'm just solving for x. Now you can do many things here. 10x, 4 times 10, just note that is a times symbol, that is an x. Not the same thing. So that's 40 that I can multiply into the bracket to get 40x. And then 40 times 7. Cricket sound. 280. And I have my same right-hand side. So 10 and 40, that gives me 50 x's. I can add 280 on both sides. 870 plus 280. Not everyone at once. 1,150. Squeeze it in. Then I divide both sides by 50. What is that?
25.
25, really?
Oh, 23.
23. All right. So, concluding sentence that I'll squeeze in over here. Now I check my question. Make sure that I answer everything they are asking and sort of in the same words as well. How long was each book overdue? All right. The astronomy book was overdue 23 days. The novels were overdue how many days? 16 days. Easy or difficult? You're going to have to tell me, otherwise I don't know if I should put it in the quiz or not.
In between because of the wording.
Yeah, I find this one a little bit.
Read it a few times for sure.
Yeah, there's no harm in that. There's no harm. You read it as many times as you need to, according to the needs of the question. Definitely. But when I look back at it, yeah, maybe the equation's a little bit more messy, but it's no different in terms of the steps that I go through. The steps are exactly the same. 4 steps. Any questions on that? Maybe that day of rest is not good. Yes?
I feel like it might have made a little bit more sense with like the way the questions worded. If X represented it was reversed.
Yeah, absolutely, and you can do that.
What?
Should we do that? See how it looks? Maybe we should. I mean, the key is that we'll do it in a short way. You choose which variable you're using and what you want it to be. Let's use another letter. Let's use a y. And let's say y then represents the number of days. What's that? Of days. A novel is overdue. Overdue. That's what you want. And at the beginning, I might not know. Well, how should I define it? What's the best, most convenient way to define it? Don't know. Looking back, you might say, oh, yeah, maybe something else, and then you can totally go back. I still need to know the astronomy book is overdue. How many days?
Plus 7.
+7, y +7. And yeah, you could argue that feels a little bit more intuitive in terms of getting the information out of the question, absolutely. Then, or so, we used it then already, how I set up the equation is the same. Right? I'm going to get to an 870. And perhaps these are a little easier. Plus is definitely easier than minus, perhaps. So, let's do the novel first. This is a single novel's number of days. So, what is the fee for a single novel when it's overdue y days? 10y. But I have 4 of them. So, multiplied by 4. Plus the fine for the astronomy book, 10 cents a day, y +7 days. We're so close, why not finish it? 40y, 10y, and a 70 equals 870. So 50y plus a 70 equals 870. Subtract 70. 50y equals 800. Then divide both sides by 50. Y equals 60. So of course my answer should be the same. Then you can look at that and say, yeah, maybe it's easier. I just went with what you defined, right? It doesn't matter. Doesn't matter. But to set it up, maybe it's a little more intuitive. Sure, perhaps. Yeah. But you should be able to get there regardless of your choice, as long as you stick with that choice. And then you can finish the rest very easily. So it is good to know that it doesn't really matter if I define my variable in a slightly less convenient way, everything would still work. But I'm of course taking the time to think about what do I think is the most convenient variable to use, because it could make things a little bit easier. Alrighty, 1614. I didn't erase this very well. Let's see if 1614 is more difficult, more confusing. It's not even really difficult in the sense that they're all the 4 steps I just have to go through. Let's see. Kai, Paul, and Judy made $2,520 for painting a house. Kai worked 30 hours, Paul worked 50 hours, and Judy worked 60 hours. They divided the money in proportion to the number of hours worked. If they all earned the same rate of pay, how much did each earn? What do you want to call your variable?
Hourly wage.
because that is exactly what well, that's not really what they're asking. They're asking for, in total, how much did each person earn. But because I know the hours, if I can find the hourly wage, I would be able to answer the question. What do you want to call it, though? W represent the hourly wage. And yes, defining the variable does get easier if I put some thought into it first, help set up the question, make the rest potentially easier, and the more I do it, the easier it gets. Then, they're looking for three different things, really. But if I can find if I can represent for each person the total amount that they made, it has to add up to 2520. So I can break it down. Who's first? I just read. Doesn't really matter. Then Kai made how many? Paul made a certain number, and Judy made a certain amount that I can now figure out. Because they say Kai worked for 30 hours. 30 hours at $W per hour. How do I calculate his total amount of money?
30 times W is equal to 25.
30 times W. Well, I don't know yet. I've broken them up, right? 30W. Paul? 50 hours W dollars per hour. And Judy, can't remember. 60. Together, that should add up to 2520. So 30W plus 50W plus 60W should be 2520. And there's my equation. A little simpler than the previous one, I would say. So I have 8140 W equals 2520. I'll continue here so it's not too low. W equals, well, I divide both sides by 140. What your calculator says? 18. Nice. 18. Did I answer the question? No, yes and no. To someone that doesn't understand variables, no. I'm going to have to really spell it out for them. And I look back at my question and ask and see what did they ask for? How much did each person earn? So I'll have to write that out. Tedious perhaps, but as clear as possible. So here's my concluding sentence. Kai made or earned or whatever 30 times 18. 540. Paul is next. Paul made 50 times 18. 900. And Judy made 60 times 18. 1080. Now you have a little check. If you add those up, they have to add up to 2520. And if it doesn't, then something went wrong somewhere. It's hard to say what. Easier? Yeah. Also based on your experience, right? If you have experience with overdue library books, this might not be so strange. If you have experience with earning an hourly wage, then this won't be as strange. So it depends. It depends on your experience. It depends on your experience from word problems, all kinds of things.